Hello, everyone. Welcome to this course on installation and commissioning of electromechanical equipment. I am Chui Ming Jun. Today we will study Chapter 3, PLC Program Controlled Punching on the Training Bench, Ladder Diagram Design, Part 2 Punching Process and Advanced Control. Let's continue to explore ladder diagram design, with a focus on the electrical control of automatic punching equipment. This is a highly practical and innovative task that requires not only a solid foundation in electrical control principles, but also acute logical thinking and rich hands-on experience. We will explore this topic from the following parts. 1. Initial setup and motion commands. Let's begin with Program Segment 14. When M5.0 equals 1, timer T37 is triggered with a 2-second delay. This provides essential preparation time for the subsequent actions. Next is Program Segment 15, which handles positioning for multiple punching points. When position flags such as M5.1, first hole, and M5.3, second hole, are set to 1, the main subprogram executes motion commands to move the punching mechanism to the corresponding positions. After the movement is completed, timer T38 is triggered with a 0.5-second delay to ensure mechanical stability. In program segments 16 to 17, the focus shifts to resetting the mechanism after punching. When counter C3 reaches its preset value, the punching mechanism returns to the highest point, i.e., the home position of the AC motor. Here, timers T39 and T40 are used with a 0.6-second delay, respectively, to ensure the mechanism returns to the initial position accurately and smoothly. 2. Tool change and cylinder control. Program segment 18 focuses on the tool change operation. When both cylinder 1, M6.1, and cylinder 2, M7.1, for tool change are set to 1, they extend accordingly. Once the sensors, I2.5 and I2.6, for positioning cylinders 1 to 2 detect that the cylinders are in position, timer T41 will be triggered with a 1-second delay to ensure the stability of the tool change process before continuing punching. Program segment 19 centers on the control logic of the cylinder solenoid valves. When M5.0 equals 1, indicating the start of automatic punching, the tool change cylinders extend to position. At this time, the solenoid valve Q1.4 is energized, opening the air circuit and driving the cylinders to extend, thus securing the tool holder. When the tool change cylinders retract and the punching is complete, the solenoid valve Q1.4 is de-energized, closing the air circuit, retracting the cylinders, and unlocking the tool holder. 3. Operation and disengagement of the electromagnetic clutch. In program segment 20, we control the operation of the electromagnetic clutch. When flags for punching the first hole, M5.2, and punching the second hole, M5.4, are set to 1, the brake is set to 0 and the clutch is set to 1, thereby enabling the punching mechanism to engage with the AC motor's rotating shaft. Each time a punching command is received, the two engage once. A total of 9 engagements are needed to complete the punching of 9 holes. Program segment 21 explains the conditions for clutch disengagement. In automatic mode, when I0.6 equals 1 and the AC motor is at the home position, I1.5 equals 1, the clutch disengages, separating the punching mechanism from the motor shaft. As explained in program segments 20 to 21, since the motor's home position corresponds to the topmost position of the punching mechanism, each time a punching operation is performed, the mechanism engages with the motor shaft, but once it rotates to the top and reaches the home position, it automatically disengages, halting the punching mechanism. Throughout the entire punching process, 9 engagements and disengagements occur. 4. Hole position movement control. program segments 22 to 23 provide a detailed description of the control logic for moving the punching mechanism between different hold positions. For example, when the memory bit for the first hold position, M5.1, is set to 1, we assign -130 to VD46, x-axis, and -80 to VD106, y-axis. Then execute the subprogram to move the x and y-axis, guiding the mechanism from the home position to the first hold position. Similarly, for the second, third, and subsequent holds, corresponding values are assigned and movement commands are executed to ensure the mechanism accurately reaches each hold position. 5. Homing after punching. Program segments 24 to 25 focus on the operation of returning to the home position after punching is complete. When either the flag for homing after punching M8.0 or the reset flag M0.2 is set to 1, we assign 500 to the x-axis, y-axis, and turret, then execute the subprogram to move the x, y, and z-axis, guiding the mechanism back to the home position. In program segment 25, the trigger conditions, sensor-linked flags, and completion conditions are described in detail to ensure accuracy and safety during the homing process. 6. Punch counting and display. Finally, program segments 26 to 27 introduce the punch counting function. Using counter C3, the system tracks the number of punching operations, and the counter is reset at the end of the punching process. In program segment 27, the counting result is transferred to VW0, allowing the HMI to display the number of completed punches, enabling operators to monitor punching progress in real time. 7. Summary. In this lesson, we have learned the design method of ladder diagrams for the electrical control of automatic punching equipment. From the initial setup to homing after punching, from tool changing operations to cylinder control, and from the operation of the electromagnetic clutch to punch counting. Each program segment is closely interconnected, together forming a complete automatic punching control system. Lastly, please complete the exercises after class. That's all for this lesson. Thank you for your attention. See you in the next class.